Imagine you're a modern-day prospector, not searching for gold, but for truth. You're handed a single number, the average gold concentration in a vast territory. The number looks promising, but the real treasure, or perhaps the biggest risk, lies hidden in the story that number doesn't tell. Today, we're exploring 4 surprising and powerful ideas from the world of statistics that reveal the hidden complexities, the unseen challenges, and the incredible capabilities of data. These concepts will change how you see the numbers that shape our world. First, the average is often a mirage. The average, or the arithmetic mean, is a useful starting point, but it can be incredibly deceptive. It's meant to represent the center of a dataset, but in doing so, it can erase the most crucial context: how spread out the data really is. Imagine you're a geologist deciding between 2 potential gold deposits. Your team has taken 5 core samples from each location. From the first location, the gold concentrations are 20, 35, 50, 65, and 80. From the second location, the concentrations are 48, 49, 50, 51, and 52. Now, here's the catch. Both of these sample sets have the exact same average gold concentration, 50. So, which deposit would you rather invest in? The average doesn't help you decide, because the real story isn't in the center. It's in the spread. The first sample is a high-risk, high-reward prospect. Its values are all over the place, suggesting the gold is distributed unpredictably. You might strike a huge vein with a value of 80, or find next to nothing with a value of 20. The second sample, on the other hand, is stable and predictable. You know almost exactly what you're going to get. The average gives you a single coordinate, but without understanding the spread, you don't know if you are standing on a single gold coin or the edge of a vast, rich vein. Understanding this risk is the first step. But what if the entire region seems chaotic? Our next truth shows us how to find a reliable map even in that chaos. The second surprising truth is that order can emerge from chaos if you know how to look. This brings us to the central limit theorem, one of the most powerful and surprising ideas in all of statistics. It reveals a profound truth: you can find perfect, predictable order even in the most chaotic systems. Here's the core concept. Imagine the data for a whole population is messy and follows no predictable pattern, like the concentration of gold across an entire, vast region. Now, what happens if you take many smaller, independent samples from that region and calculate the average of each one? Something amazing happens. The distribution of those sample averages will almost always form a perfect, predictable bell curve, also known as a normal distribution. This is true even if the original data you started with was not normally distributed at all. It's frankly magical because it's a universal law of data. It guarantees that we can find a stable, predictable pattern, the bell curve, from the averages of samples, even if the source population is a chaotic mess. It's how we pull a clear signal from the noise. This is incredibly impactful because the normal distribution has well understood properties. The central limit theorem allows analysts to make reliable predictions and use powerful statistical tests on real-world data, which is almost never perfectly neat and tidy. It's the secret weapon that lets us find certainty in uncertainty. Now for our third truth, and it's a bit of a reality check. The real work of data analysis isn't the analysis itself, it's the janitorial work. The secret of successful data analysis isn't some brilliant algorithm or a beautiful chart. It's the unglamorous, painstaking work of data cleaning. Before any insightful analysis can happen, analysts must first become data janitors. Raw data from the real world is almost always messy, incomplete, and full of errors. Before making any predictions, a huge amount of effort goes into cleaning up common problems. There might be missing data, like empty cells or not applicable values that need to be removed or intelligently filled in. Then there are outliers, wildly high or low values that could be simple typos or genuine, rare anomalies that need special attention. You also have inconsistent text. Imagine a country field with entries like CAA, Saudia, and Saudi. They all mean the same thing but must be standardized for the computer to understand them. You'll also find duplicates, where the exact same piece of information is recorded multiple times, which can skew results if not removed. And sometimes you find logical contradictions, absurd data points that defy common sense, like a person whose age is listed as 5 but whose job title is manager, or a salary entered as a negative number. This meticulous cleaning process is the foundation of all trustworthy analysis. Without it, even the most sophisticated algorithm will fail, because of a simple, unassailable truth in data science: garbage in, garbage out. This brings us to our fourth and final truth: statistics can create a treasure map of the unseen. It's impossible to sample every single point in a geographical area. A geologist might have gold concentration data from 20 drill samples, but how can they possibly know the concentration in the vast, unsampled areas between those points? This is where a set of techniques called spatial interpolation comes in. Methods like kriging are the statistical solution to this problem. They are a sophisticated way of connecting the dots that goes far beyond simple averaging. This isn't just guesswork. These techniques use powerful mathematical tools to understand the spatial relationship between samples, how the gold concentration at one point relates to others nearby, before drawing the treasure map of the unseen. The power of this is astounding. For example, if you have 20 samples of gold distributed in an area, geostatistics helps you know the pattern of the gold spread, predict its concentration in places you haven't sampled, and even calculate the total reserve for the entire region. Think about how incredible that is. Using just a handful of known points, statistics can generate a complete, predictive treasure map of a resource, effectively allowing us to see what is physically unseen. It's the closest thing we have to a data-driven crystal ball. So, let's recap. Data is far more nuanced, messy, and powerful than a single number can ever convey. We've seen how the simple average can be a mirage, yet how a predictable order can emerge from chaos. We've uncovered the secret janitorial work that makes analysis possible, and learned how a few known data points can create a treasure map of the unseen. These four truths show that data isn't just about finding answers. It's about asking the right questions and appreciating the hidden stories. The next time you encounter a statistic, don't just take it at face value. Look beyond the headline. What hidden story will you look for? Thanks for watching. If you found this interesting, consider subscribing for more insights into the hidden world of data.